Okay, so just a little quick thing. I'm not actually going to be explaining any of the topics at all. I'm just simply going to be metagaming the exam, telling you what topics turn up 100% of the time, what topics are less likely to turn up. Yippa yappa yippa yap. Another thing to note: this is from old papers because they've only given us papers from like 2012 to 2017, which is inconvenient. But I'm assuming they have like the same topic consistency and whatnot, right? Not the point. Basically, the 100% guaranteed topics, which turned up in like all of the papers, is the DC circuits and resistor networks topics, AC signals, RMS, frequency and phase difference, diodes and rectifiers, op amps, transistors as switches. I'm going to be going through like the equations you need to know and the topics within these broader topics and whatnot, right? So first one, DC circuits and resistor networks. This has appeared in literally every single paper that they've given us, right? Unsurprising because it's like the first lecture, not the point, right? But this includes series and parallel resistors, voltage division and current division, power dissipation in resistors, equivalence resistance calculations, and then Thevenin equivalence. These are all your equations you need to know. Most of them are pretty like standard that you should know, you know. This Thevenin, if you don't know what it is, it's basically just like, to put it simply, like batteries, like AA batteries, they tend to have like a voltage of 3.5, right? But then when you actually plug it into something, it only has a voltage of like 3.2. That's because the internal resistance of the battery actively lowers the voltage, right? And that's just what this is. This is like the voltage without it being plugged in, which is why this is. Same thing with resistance as well. Anyways, for AC signal, RMS, frequency and phase difference, again, appears in literally every paper known to man. It includes the RMS values, which is root mean squared, if you don't know what that is. It also includes sinusoidal expressions, sick, power in AC circuits, heater circuits using AC. These are all your equations, right? Pretty bog standard, not a lot of equations, but what you do need to know thoroughly is this right here, right? And in case you don't know what this is, little overview. This is just simply saying the voltage at this specific time equals blah. And obviously if we have the graph, it's pretty easy because say someone's like, oh my days, what's the voltage at 25 milliseconds? You go 10, 20, 25, you go up, no way, 6 volts, yes now, and that would be your answer, right? But obviously we won't have this diagram, so we would need to go by this equation. Yeah. It's all pretty standard here, except this is phase difference if you didn't know. And yeah, peak. Digital logic, Boolean simplification, and K-maps. Again, appears in literally every single paper. Topics include simplifying Boolean expressions, designing logic circuits, drawing logic symbols, and K-nar maps. Who knows how to pronounce that, bro? K-maps. Combinational logic design problems, often like real world themed. Like the questions themselves will go around like a real world problem and then ask you to sort out with logic, right? These are all your like equations that you're going to be bringing into like, not the equations, but these are what you like should know from being able to simplify Boolean expressions. Yeah, sick. And you can verify these if you want, like for instance, like this right here. Like it's pretty simple. You just flip in, oh no, A can either be 0 or 1. That means A can only be 0 or 1, because you can't have like different values for the same thing, you know? Like you can't have A being 0 and 1, because you just can't, right? And then you go, oh my days, A has gone into this OR operator twice. So that means, is A 1? No. No. So it's false. Is A 1? Yes and yes. Oh, sick. And then you're like, wait, but this is the same as just saying A. And then, yeah, you pretty much proved it with that. So that's how you can like prove literally each one of these, especially these ones. And in case you're wondering what these are, I know it's so difficult to format, I'm sorry, but like these little lines, these are knots, and these lines down here, like the big knots, where this is like not A and B, right? Where this is not A or not B, and all that. Anyways, op amps, again, come up in every single paper just because it's how they format the paper, right? This includes inverting and non-inverting amplifiers, closed loop gain, effective feedback, input and output resistance, and these are all your equations you need to know. These are your assumptions for ideal op amps, obviously your equations. Again, if you don't know this, then there are like YouTube videos at the end that I'm going to link you to, right? Not the point. Next one, diodes and rectifiers. Again, appears in all papers. It includes half wave and full wave rectifiers, average DC output calculations, adding smoothing capacitors, ripple voltage, and then Zener, whatever man, diodes and voltage regulators, right? Super duper common. These are like guaranteed to have one of these questions come up in the exam. Not even funny, right? These are your equations. Yeah, just pretty much learn them, like lock them in, understand what they do, and yeah, that's pretty much it for that one, right? Transistors and switches, again, appears in all papers. Topics include base current calculation, collector and emitter current, ensuring saturation, switch circuits. Transistor as switch question is extremely likely. It appears in all papers, and even though it's not like a main topic in the course, for some reason our university just loves to throw a transistor as switch question in there. These are all the equations you kind of need to like clock, right? Yeah, I know they're pretty intimidating and scary, but hopefully after some videos watched, they'll be okay, right? And so the topics before, like if you just learn all those base topics, you're gonna easily pass the test, right? You're gonna easily get above 50%. You're probably gonna get like 60, 70%, and it's gonna be free, right? But if you're like wanting to excel and exceed, here are the topics that are like less frequent come up, but they obviously do come up in the exam, right? Got the EM waves and photon energy, sensors, actuators, and amplifiers. Concept questions. Oh. System design questions, specifically closed loop systems, right? These are all your equations. This is precisely why I've decided to put these all together, because there's a lot of equations and you don't really need to know them to pass the exam. But you kind of do need to know all of these if you're wanting to like do, I don't know, thoroughly well in the exam, right? And here's a little summary of just all the equations that you kind of need to know. Obviously, we're excluding stuff like this, where if you're trying to convert it to decibels, then it's just like that, right? We're assuming you know this. These are the actual equations you need to know, right? Alrighty, so future me here. I'm just looking at the video, and obviously it's all cool and whatnot. Obviously, I've pretty much stopped it here. I did have a bunch of YouTube links, but the issue is I didn't actually like look at them. I literally searched up DC circuit and resistor networks, like clicked on a like thumbnail that looked acceptable through the link and then called it a day. Turns out, like after looking back at them, none of the links actually work. They're genuinely terrible, right? But the point I made during this like little section of the video does still stand, that you should basically just like watch a video on each of the topics. So for instance, the transistor as switches topic, you should like look at a video on what saturation is, look at a video on like transistor as switch questions, and pretty much just learn the content which I've outlaid here. And I know it's a lot of content, but this stuff literally comes up on 100% of the papers. Like all of the papers have this logic, all of the papers have like, you know, this, like they all have this, right? But I've just laid it out in a pretty nice, reasonable manner in which you can learn it yourself. And for instance, if you wanted to like, I don't know, choose one of these topics, literally just go K-map explanation, and then boom, you'll have like infinite videos that tell you what the hell K-maps are. And yeah, you can literally do the same. Like for instance, you could just throw in power dissipation and resistors into YouTube, and you'll get like such good results, right? Another point, but that's how I recommend you guys like go about your revision and learn. You just literally throw in these minor topics into YouTube and then learn that way. Don't go to any of these, because goddamn, that fucking sucks. But also what I was saying is, if you just literally want to pass, just learn these 6 topics. What I'm talking about is like learn DC stuff, AC stuff, Boolean stuff, op amps, diodes and rectifiers, and then transistors and switches. And then you're literally guaranteed to get like 80%, 70%. And then if you're trying to be a little bum sweat and get like really good grades, then do this stuff, you know, EMF waves and photon energy, sensors and actuators, design systems and closed loop systems, right? Sick. Yeah, that's about it. Yeah, bye bye.